For question 1, one of Jupiter's moons has an orbital period of 212.4 minutes. What is the mean orbital radius of the satellite and its speed? Assume the mass of Jupiter is 1.899 times 10 to the 27 kilograms. Have a go at this question, and then I'll go through this question, and let's see how you get on with this question. Question 2. A moon has a satellite and it orbits 1,600 kilometers above its surface. Calculate the speed of the satellite and its period. Assume the radius of the moon is 1,737 kilometers and the mass of the moon is 7.342 times 10 to the 22 kilograms. Have a go at this question.
All right, so the question is, one of Jupiter's moons has an orbital period of 212.4 minutes. What is the mean orbital radius of the satellite and its speed? Assume the mass of Jupiter is 1.899 times 10 to the 27 kilograms. All right, so you've got these pieces of information. I've converted the minutes into seconds. So here I'm going to use t squared is equal to 4 pi squared divided by gm r cubed. So rearrange for r, we get gm over 4 pi squared t squared and then all cube rooted. Okay, so I've put the numbers in, and so g is 6.67 times 10 to the minus 11. You know, mass is 1.899 times 10 to the 27. Now I've divided it by 4 pi squared, and I've multiplied by 12,744 squared, and all of that is cube rooted. And you should get 80,470 kilometers. Or in meters, you can say in meters, it is 80 million, around about 80 million. So 80,470,036 meters. And then the other question was work out the speed. So in this case, I used v equals r omega, and you know that omega is 2 pi over t. So v is equal to 2 pi r over t. I've put all the values in. So you know that you've just worked out r was 80,470 kilometers. And then all of that multiplied by 2 pi, and I've divided that by the period. And then the period was up here. So 12,744. So then your final answer is 39,674.2 meters per second. And for this question, I've put down the data. So the radius of the moon is 1,737 kilometers. The height above the surface is 1,600 kilometers. And the mass is 7.342 times 10 to the 22 kilograms. Now the question is, calculate the speed of the satellite and its period. So t squared is equal to 4 pi squared over gm r cubed. So t squared is 4 pi squared, and you know that g is 6.67 times 10 to the minus 11. Now for the moon's mass, and then you multiply by r cubed. Now in this case, the r is the radius and the altitude together. So it would be 1,737,000 plus 1,600,000, all of that cubed. Alright, so I've put the numbers in, and then I've got t squared is equal to 299,562,980.3 seconds. And then, sorry, that should be seconds squared. And then you need to take the square root, and then you end up with 17,307.8878 seconds. And then for the second part of the question, it was to work out the speed. So you use 2 pi r over t. 2 pi r is the distance around the circle, t is the period, the time it takes to go around once. So I did 2 pi, and then remember you have to include the radius and the height. So the radius was the radius of the moon. The radius of the moon was 1,737 kilometers, and you need to add on to the height. So that's the total distance from the center of the moon, and then divide that by the period, which is 17,307.8878, and then you should get 1,211.4 meters per second.